Hello, everyone. We'll wait a few more seconds. All right, we're going to go ahead and start. Thanks, everyone, for joining the session today. And today's talk is, let me find one more thing. Sorry, my screen is. All right, sorry about that. Some technical difficulty. Welcome, everyone. In this session, we have Victoria. She's a data scientist at the Breakthrough Energy Science, presenting this session on modeling impact of investment in emerging climate technologies. Just a quick note to everyone that please post your Q&A questions in the Q&A box instead of the chat. Victoria, a reminder to set your timer. Off you go.
Thank you, Hani, for that introduction. Hi, everyone. Thank you for being here today. My name is Victoria Hunt, and I am a data scientist for Breakthrough Energy. Today, I'll be talking about modeling impacts of investments in emerging climate technologies. My talk will be a whirlwind tour of the way that we do impact analytics at Breakthrough Energy for emerging climate technologies. For more information, there is a detailed report that is shown on the right-hand side of the screen. It's co-authored by CDP, the Carbon Disclosure Project, and Breakthrough Energy. And if you're interested and want to learn more after my talk about this project, I'd encourage you to check it out. I will go through the introduction and the motivation for why we've developed this impact analytics framework. I'll also talk about how we set up the simulation and the model that we use to assess the forward-looking impacts of investment into climate technologies. And then I'll go a little bit deeper into our forecasting methodologies. We forecast the impacts of investments into climate technologies in two key areas, which are in the cost decline, the way that the costs will go down in the future for these technologies, and in the emissions avoided by the earlier adoption of emerging climate technologies. And then I'll talk a little bit about next steps and where we see this project going from here. To set the stage, Bill Gates wrote about this project in a publication called Financing the Clean Industrial Revolution. And I think that this quote really sets the stage for the work that I do and for this project. It explains the motivation of why we need this framework in the first place. So Bill Gates said, the price of avoiding a climate disaster should not be telling billions of people they cannot build their futures. That would just be trading one disaster for another. It is much better for the world's shared destiny if the price of avoiding a climate disaster is the money and the collaboration it will take to radically accelerate innovation. So this framework seeks to explain the mechanism by which early investment can radically accelerate innovation. And we know that radically accelerating innovation in emerging climate technologies really is necessary to achieving some of the world's goals, such as a net zero by 2050 future. This framework specifically applies to a certain kind of emerging climate technology. These are technologies where they're past the technology development and company building phase, but they're not yet at large-scale commercialization. Unfortunately, there is this valley of death, it's referred to, in the commercialization life cycle, where investment is often slow at this point between technology development and large-scale commercialization. So this project seeks to incentivize investment into this critical time in the commercialization life cycle so that technologies can get to scale sooner and can be adopted at scale sooner, and therefore see these emissions reductions earlier. Specifically, we are using 4 pilot technologies at this time to assess, and these pilot technologies are long duration energy storage, direct air capture, sustainable aviation fuel, and green hydrogen. These are all technologies that are currently at this technology readiness stage after technology development, but not yet at large scale commercialization. So there are investment opportunities, but they're not yet they're not yet cost competitive against the incumbent fossil fuel technology that they would replace. This is the basis for the framework in a nutshell. We have technologies that we expect to diffuse into a given market over time, and we need to accelerate that process. So in this plot, in the purple, you can see the expected deployment of an emerging climate technology. In this case, this is actually a historical example, and it's showing adoption of solar, PV solar. You can see that between 2010 and 2020, we've seen a lot of adoption of this technology. However, what if we had invested more money, potentially $5 billion more money, in the 80s when this technology was really being slowly rolled out? So we would expect that that would accelerate market adoption of the technology. And at the same time, that accelerated technology would achieve economies of scale, and we would see a corresponding decline in the cost. So that's in the blue. And this is really necessary because we need to have increased adoption of these technologies because each unit of this technology is replacing a fossil fuel incumbent. And so we expect to see emissions avoided sooner, which is better for the climate change impacts of these technologies. The issue here is that currently emerging climate technologies are very expensive. And so how do we look forward and explain the mechanism by which they would have a bigger impact without relying only on a current day cost analysis? So looking a little deeper at the cost decline portion of the historical solar PV example, we would expect that we would have a 47% cost decline with that early $5 billion investment had there been that early investment in solar. So again, drive down the costs earlier, drive the acceleration sooner, and then see those emissions reductions occur sooner. One of the ways that we think about the cost in particular is using a metric called the green premium. The green premium is defined as the difference between the cost of a climate-friendly product and a fossil fuel incumbent or a incumbent technology that emits more greenhouse gas. One of the challenges is we may know the green premium currently for a given technology, but to have these forward-looking impact assessments, we also need to do forecasting of the costs for both the clean technology and the incumbent technology. So I'll get into that forecasting methodology a little bit later. And in this graphic, we really want to drive down the green premium so that we have a closer cost between the clean technology and the high emission technology so that it can be adopted at scale. The framework has three main steps. The first is that we assess the adoption of the technology in what we refer to as a sort of middle of the road scenario. So we make projections of how quickly and what the market dynamics would be of technology adoption with expected policy and expected market conditions from now until 2050 and beyond. From this, we generate a technology deployment curve that shows installed capacity of the technology as a function of time under those expected conditions. The next step is that we estimate the impacts of an early investment. To do that, we do two things. We estimate the proportion of the investment that can be absorbed into the market, and then we evaluate how much time we expect that early investment would actually accelerate market adoption. And that's based on the capacity scale up that was due to that investment. So after we've done those two analytical steps, we then have a cumulative installed capacity as a function of time in the catalyzed case, which is the case with the early investment. And then lastly, we have two assessments for the main or key impacts of interest, which are the green premium or the cost and the emissions avoided. So to assess those two key impacts, we assess the difference between the baseline case and the catalyzed or early investment case, and then look at that differential and report back on the expected impact between time of investment and 2050 for the specific investment case. Currently, this framework exists in a GitHub repository. It is a private repository at this point, but we do ultimately want to make this publicly accessible and also technology agnostic, so that any technology, if the user has the parameter values, would be able to, any user with any technology question would potentially be able to use this tool. It is currently in private repository in Python, and we use Jupyter notebooks to run different investment scenarios. So this is explaining those steps that I showed in the previous slide, but in the way that we actually process them in our repository. So getting back to those steps, the first one is translating the investment to its impact. And one of the considerations for emerging climate technologies is that there really potentially aren't that many investment opportunities. As the technology scales up, there will be more, but there's really only so much capital that the market can absorb at a point in time. So to account for this, we use a what's referred to as a convex cost of adjustment. Basically, up to a given point, your investment is assumed to be 100% efficient, meaning $1 of investment is able to buy $1 of capacity for that technology. At a certain point, because of the fact that it is an emerging market, you might then expect that for different technologies, there's a different point at which your investment becomes decreasingly efficient. And so that's in this plot I1. You can see that now as you add more investment, less of it can be absorbed into the market. And at a certain point, at a very high investment amount, potentially the infrastructure isn't able to be built out in time. Potentially there aren't investment opportunities for these emerging climate technologies beyond what's been funded. And so that's where you see I2. And at that point, no more investment can be absorbed. After we do that translation, we then look at, once the investment is expected to increase the capacity a certain amount, how much time does that actually save the market? And so here you can see this red line is showing at what point in the baseline case would we expect that capacity to have been achieved without that early investment. And so from there, we then essentially shift the curve earlier in time, and we then assess the impacts of that earlier technology deployment. And so one of the key questions that you might have at this point is, where do we get the baselines? They're obviously very important. And this is a whole modeling effort in itself. And we are working with the Rhodium Group, who's developing an extension of the World Energy Projection System to develop and provide these baselines to us. The way that we think about cost is using something called Wright's Law. In short, Wright's Law says that with each doubling of production of a technology, you expect to see a certain proportional decrease in the cost due to the economies of scale. So this is showing an example, and this is how we think about the cost decline. So if you can increase your production of a technology sooner, you would expect to see that cost decline sooner, because it's all about the cumulative production of that technology driving down the cost. So this gets a little bit more into our cost dynamics, and you can see that we have assumptions we make about the rate at which learning is taking place, the rate at which this cost is going down due to the increase in production. And then we have the production in the baseline case and in the catalyzed case. And so we compare those two to assess the change that was due to the early investment. This is an example showing what we might see in terms of the expected reduction in cost had there not been that early investment, and then the additional decrease in cost that we would expect to see with that early investment. The other key metric that we look at in this project is emissions reduction. Earlier emissions reductions is key to avoiding the worst impacts of climate change. And so for this, we look at each unit of the clean technology is assumed to be replacing something in the market. It can be something or some things, but there is an associated emissions reduction because the emissions produced by the one unit of the clean technology are less than the fossil fuel technology. So that difference is the carbon abatement factor. And we look at the carbon abatement factor over time for the clean technology and then assess how much has been saved in the case with the early investment relative to the baseline. The other thing that we do is we apply a discounting factor, which is used to actually value earlier emissions avoided more than later emissions avoided, because again, from a climate standpoint, it's very important to avoid emissions as soon as possible. And so while we're looking forward at future emissions avoided, we also want to value those earlier emissions avoided more highly. So this is showing what we would expect to see with the emissions avoided over time for the catalyzed case and the case with the early investment and the baseline case. In both cases, the technology is being adopted in the market. So you do see emissions avoided from that technology adoption in both cases, but in the catalyzed case, you see more emissions avoided. And also due to this discounting, you see that they are valued more because they occurred earlier in time. Earlier in time. So one of the analyses that we have done so far with this framework, which I wanted to share with you, is that we've compared a net zero by 2050 scenario and a expected technology deployment scenario to look at what is the potential of these technologies if we were able to achieve a very high level of early investment and really drive this early adoption of technologies. So in the net zero by 2050 scenario, the 4 pilot technologies, which again, green hydrogen, sustainable aviation fuel, long duration energy storage, and direct air capture. Those 4 technologies, if we were able to have that early influx of investment necessary to achieve scale much sooner and achieve a net zero by 2050 scenario, we would expect to reduce up to 7 gigatons of emissions annually. So this is a big impact and a big step towards actually achieving this net zero by 2050 future that we all hope for. We can also look again at how much time we save. We would expect these technologies to scale eventually, but how much sooner could we scale with that large influx of early investment? And here you can see we have different expectations for different technologies based on market dynamics, but it can be potentially decades saved. Lastly, for next steps, we are currently working on a repository. The code is in Python, and ultimately, as I mentioned, we want to have that be open source so that users can explore the tool, use it to consider different investment opportunities and different impacts of technologies and early investment into those emerging climate technologies. The other next step is that we currently use a Jupyter notebook, but we are working on a web-based dashboard, and that's under construction currently, but that would be a great way to have more accessibility to the tool and potentially have more users be able to explore and learn about the emerging climate technologies. So that concludes my presentation. I wanted to say thank you again so much. And for more information about any of the steps that I very quickly went through, I would direct you to this report. And you can also please feel free to reach out to me. I'm at victoria@breakthroughenergy.org, and my Twitter and LinkedIn handle are going to be shared by Hani in the chat as well. Would love to hear from you. And thank you also to all of the different groups that have worked on this project: Rhodium Group, Breakthrough Energy Sciences, CDP, Boston Consulting Group, and many other partners. Thank you, and I can now take a few questions.
Awesome. Thank you for the presentation, Victoria. Let's see. We'll transition to Q&A. I don't see any questions yet. Feel free to post your questions in Q&A that you have for Victoria. If you want to reach out to her later, I have posted her LinkedIn and Twitter. I do see one question coming in. So the question is, are you looking at using any package, library, or software in particular for creating the web-based reporting?
So currently we have rolled this framework out only for the 4 pilot technologies, and it is used within Breakthrough Energy Sciences, but not widely used outside of that. Ultimately, we do want to have the GitHub repository be open source. As far as the web-based question, we haven't in particular gotten too far down that discussion. We're building out a web dashboard currently. I would say one other interesting project that people could check out is that Breakthrough Energy Sciences also has a very high resolution model of the US electric grid. And so we have a dashboard for that project, which you can check out, and also an open source code repository for that project. And so we're, in my mind, we're following in that footsteps of that sort of effort. So we have a dashboard where people can explore and interact with the data. And then we would have the code base for people that are interested in actually running the model themselves.
Awesome. Hopefully that answers your question, Melinda. Do you have a link to the dashboard that you just discussed that I can post it here?
No, the dashboard isn't yet public. So the thing that I would direct you to is that report, which is at the link that's on this screen, and then the dashboard is still under construction. We also do on the Catalyst page. Catalyst is the fund that invests in emerging climate technologies for BE. On that page, there's also a video explaining the dashboard as far as what we expect it to do, but it's not yet public.
Okay, we have another question. Oh, I thought there was a question. I don't see any other questions here. Anything last minute that we want to share with our audience?
No, thank you very much for your time, and looking forward to the rest of the talks. And if you have any questions that come up later, please feel free to reach out.
Yeah, thank you so much for the great presentation, Victoria. This concludes our session. If you have any additional questions for our speaker, you can send her a direct message to Accelerate Event, or find her, as I said earlier, I'll find her on Twitter and LinkedIn. I'll post the link for her. We're looking forward to see you in the following sessions in the expo booth. Thank you.